Hello, everyone. Thank you very much, gentlemen, for attending this session, the last session and the last track. It's a great pleasure for me to speak in front of you today. Just a few words about myself. So I'm Pavel Petroshenko. I'm originally from Russia, St. Petersburg, and I worked in a number of international companies, started at Sun Microsystems back in Russia, and then moved over to here to the US, joined Oracle. I worked on multiple embedded and IoT projects. I was a part of the core Java virtual machine team, which was for like probably 10 years ago, that was running Java IMC, if you remember this. It was Java for mobile, first applications for mobile devices, and I actually was a part of the VM team there. And then I worked in Oracle in a number of IoT projects, and now I'm part of the startup, which is called Electric Imp. It's a secure connectivity platform for embedded devices. And here today I will talk about cross-platform deployments for Apache Ignite. And I will first talk about Apache Ignite clients, because this is my interest in this area, and I participated in a number of Apache Ignite clients development, which I will talk a little bit later about. We'll talk about data interoperability in Ignite, how it all works, how clients and applications run on multiple platforms in multiple languages can share the same data and work with the same data. I'll speak about in a little bit more details about binary client protocol, and we'll show the live demo. Hopefully it's going to work. It has a lot of moving parts. It's going to be live. So as you probably, many of you know, so there are two types of clients in Ignite. It's server nodes and client nodes. The server nodes are the main nodes that participate in the cluster, so they participate in caching, they do compute job execution, they process streaming data, etc. So that's the base of the Ignite cluster. There are also client nodes that are designed to primarily connect to the main cluster and to run applications. And these applications are called thick clients. And there is a reason for that. So thick clients have access to full Ignite APIs, including near caching, transactions. So you can run jobs on client nodes, so they can execute nodes, compute jobs. You can have access to the streaming API, to the services, etc. So you can implement fully functional and deploy fully functional applications to client nodes. And client nodes, they connect to the main clusters. So they require server nodes to be somewhere in the topology. So there is a way to run client nodes without the server nodes. But in general, so they need it. And there are a number of requirements when you develop your applications or thick client applications. One of them is connectivity. So we live in the real world, and connectivity, especially on the clients which run out of the main cluster, which may have limited computational capabilities, limited network bandwidth, and they can also reconnect. So reconnections should be handled by applications. They should reconnect, but there is a number of issues with that. And one of them is that, for example, the cluster node ID can change. So if you somewhere rely on this or hard code it in application, that's a bad practice. You should avoid it. Regarding so there is a notion of slow nodes or slow clients. The clients are limited in, as I mentioned, in computational power and in the network. So not all the messages from server nodes from the main cluster can reach the client nodes on time or in at the frequency that the server nodes would like. And so there may be either queuing issue on the server side or stalls or blocks. So the server should be aware of the topology, be aware of the specifics of the clients, and properly configure the limits for the cache or for the queues for outbound messages from the servers to the clients. In the contrast to thick clients, so thin clients are so they actually independent applications developed in any language that connect to the main cluster, to one of the nodes in the main cluster. And this node is called the proxy node. There is so that which actually represents this client in the cluster, and it sends all the requests to this node, which knows where to resend it to inside the cluster. So it doesn't require any client node to run. It doesn't become part of the topology of the Ignite. It cannot execute compute jobs. It has and it's basically the way it communicates to the cluster. It is defined by this binary client protocol, which we'll discuss a bit later. And as I said, it can be implemented in multiple languages. For example, in the next release, 4 clients are going to be released: C++, Node.js, Python, and PHP. So let's talk a little bit about the data representation. So different languages have different type systems, have different objects layouts, objects representation, and how to address it, how to make them all work together. They all share the same sets of data, work with the same caches. So the binary object is a concept which exists pretty long time. I think it was introduced in 1.5 version, and it's actually a cross-platform format for object serialization. So this format allows, and the APIs, binary object APIs, allow to access to arbitrary fields in objects without full object deserialization, without decoding the full object. It actually eliminates the requirement to have key and value type implementations on the server nodes, which is a very good good benefit. It also allows to modify the structure of objects dynamically. So in some applications may have different versions of the same type of objects within the cluster, or even I think within the same cache. It also allows to dynamically construct objects. So for example, a type defined by name can be built dynamically by an application. At the same time, binary objects have a number of limitations which applications developers should also keep in mind. One of them is that it relies on the name cache value. So you shouldn't have anywhere in your hierarchy of your classes, you shouldn't have the same field or the same class name which has the same hash value. And only default marshaller works can be used for binary objects. So there are 2 main recommendations regarding the binary objects representation. One of them is so there are some applications that don't allow you to deploy any code or even stream any code dynamically to the server nodes or server cluster. And in this case, binary object builder and binary objects can be very useful to dynamically access objects without the need to deserialize or deserialize them in a custom way. And also, an important thing to mention about binary objects is that, which I forgot actually, so they support SQL queries. So you can, whatever you push using this serializer, this form of serialization can be then queried by SQL requests. However, if you don't need this ability, you can optimize the data size by using binary row writer, which eliminates the reference and the tags of field names and of the type names, and it's a more compact representation in general, which helps to optimize footprint for, well, the space on the storage or when you transfer something. So binary thin clients protocol, which is based on binary object representation, defines the way how thin clients applications interact with the cluster. And as it's all about connectivity, so client applications connect to the cluster, so applications have to manage connectivity issues, disconnects, etc. There are a number of ways that thick clients, thin clients provide for applications to do this. We can talk a little bit later about this. So the thin client protocols also defines the way how the connection is established, which handshakes are made, what's been done during these handshakes. For example, the clients may implement may support specific versions of thin clients protocol, which are not supported by the server, or vice versa. So the version matching is being done, and also optional credentials exchange and authorization is being made during this handshake process. It also defines the format of messages and objects, and in general, format and layout of objects. Headers, request, response format, etc., and how it all works all together. And little ending is the byte ordering, predefined byte ordering format for the thin client protocol. So client operations are limited to key value operations, SQL queries, and there may be a number of limitations which are language specific. For example, some operations like scan with filters may require Java objects to be streamed to the server nodes, which may not be supported, for example, in clients written in Python or in PHP, for example. Supports binary type operations, of course, because it's based on this. It's native to this protocol. And cache configuration operations, primarily for type mapping, proper type mapping for specific language. So let me show you the demo. I'm running a simple cluster on an AWS instance. For simplicity, I run just one node. I actually tested it, of course, with multiple nodes. Just wanted to keep it simple for the demo here. And there are 4 different platforms involved in this demo. The first one is it's an electric imp device, embedded device, which has a number of sensors on the board. And one of them is temperature and humidity sensor. And it's connected to Wi-Fi, and it's streaming live data to this. Let me show you the diagram. So this device is using the REST APIs because it doesn't have outbound TCP connection. To connect to the cluster, thin clients have to. So it's actually TCP, raw TCP connection. This guy doesn't have this ability, so I had to use the REST APIs for that. And it actually creates a cache and pushes raw data into it. There are 2 messages being sent, key values, humidity, raw humidity, and its relational humidity, and raw temperature values. And there are 3 thin clients. One is the Node.js thin client. It's written in Node.js language. It's also running. It's running locally on my machine. I will show you the code and how it all works. It actually reads humidity and compares it to specific threshold, predefined thresholds, and creates a complex binary and creates a complex object, which is called alert or humidity alert, if the raw value, humidity raw value, exceeds some predefined value, and then pushes it back to the cache. And the same is done by the Python client with the temperature. So if under certain circumstances there are actually two pairs of objects, two primitive objects and two complex objects being pushed to the same cache. And there is a PHP thin client which runs on the server, web server, that reads all this data and shows them on the simple web page. So let's probably first look how it works. So there is some alert here. So I set the value of humidity to 80, which is the maximum one, which actually anything above will raise this, will raise an alert. And now you can see the humidity drops, and it shows normal conditions. And the temperature is in Celsius, and I think the threshold is 26 Celsius now. So if I warm it up with my finger, so humidity goes up. It actually can be greater than 100 because it's relational humidity. Oh, let's see, maybe 27 C. So let's wait. It actually polls the igniter every, I think, 3 seconds. 28. Anyway, so let's now look at the code, and we'll see how it all works, how it's supposed to work. So this is the code of this for this device. It's written in Squirrel. It's JavaScript-like language. So the right part here, so the right window shows the peripherals and hardware part of the code. So I actually create an instance of the driver for this sensor. I configure it, and then I periodically read it every 5 seconds, and then send it to this part actually. And this is how I actually send 2 messages: key value, temperature, and humidity. And here, first, it actually creates the cache, gets or creates the cache, and my cache's name is my cache. And then every time it receives the value, it puts it into the cache, the same cache, using the REST APIs. So then let's look at, so this is the Node.js client. And by the way, so these clients are going to be released shortly. I think you can already have access to the sources if you want to play and see how it works. So the code is pretty simple. An instance of the thing, so the first we create the configuration, and then so first we create, so we create the client which registers the state change handler, and the states change. So 2 states can be connected or disconnected, which you can handle and reconnect if needed, for example. And so there is a configuration where you can provide either one specific address of the node or several specific nodes. If one of them goes down, for example, the client will automatically try to reconnect to the other one. And then you just get access to, you either get or create the cache and process data. So when you process data, all you do actually, you just read humidity get humidity from the cache, and if alert condition occurs, create a complex object and just push it. So literally 5 lines of meaningful code for this operation. And very similarly, so similar things, or even simpler, happens on the Python side. So we actually and the APIs are aligned in this way. So you can provide a set or array of addresses for the client to connect to. So the client connects, and then we get access to the cache. And so if we read the primitive value first, if if the alert event occurs, we create and push the complex object, which is serialized into binary object format, which we discussed before, and put into the cache. And let me show the PHP client, which reads data pushed by the previous ones and tries to show them on the screen, as I showed before. What it actually does, it reads to over here. So it reads to objects, complex objects first, and then it also reads the regular raw value, current raw value. I use raw value to show if there are no, for example, temperature or humidity alerts. And if we switch back to any of them, so we can actually see that alert, like for example, temperature alert consists of the temperature which actually triggered that alert and timestamp, datetime. And so there are all the necessary types, including primitive types or complex types, are supported, and they can properly automatically serialized and deserialized when I've been pushed there. So let's just briefly look on how we handle these complex objects here. What we do is just so this is how we actually read the value from this binary object. We actually call getField by name. As I mentioned, the binary object format allows you to access arbitrary fields by name without deserializing the entire object. And and then it shows it this way. So I think that's all I had. Just to sum it up, it's very easy to work with Ignite, Apache Ignite, from applications written in multiple languages, in almost any language, using thin client protocol. If it's too limited for your application or you need more, you need to use thick clients, which have access to more APIs. And so I can share all the codes, the sources of the thin clients that we discussed are available already somewhere on the branches and shortly be released. Let me know if you have any questions. Sure.
Well, the first question was, how is your binary protocol different than Corbett? Maybe because it's simpler in terms of implementation. But it seems very similar to the concept of object broker back from many decades ago now. But the other question I had when I looked at the code was where I didn't really see how the classes that were defined as binary classes that ended up getting, when they would put or got or read, invoke the binary object methods, which is maybe that's in one particular class type name that was part of the framework that was a binary object definition.
Yeah, so actually, so this is sort of a magic being done by the libraries. So thin clients are actually a library that does a lot of work underneath for you to serialize and deserialize it. So this is the temperature alert class, which actually has two fields, temperature and datetime. And all you do actually here is you put it into the cache by this key.
I understand that. I'm saying I would thought that the serialization would have not been binary in this particular case. You got the thin client side and the server side, but if you are going to do binary, you have to in fact agree upon whether that's beginning and ending and all the binary issues about. I didn't see where that was defined.
Yeah. So the client protocol actually is based on the binary format. There is no way for you to serialize any. So there is no way for you to serialize complex objects into anything else. So that's the binary object format by default. However, so there may be tricky cases when you want to map some like native Ignite types to specific language types, which you can actually provide, and there is ability for every thin client library where you can provide this mapping for a specific cache. When you work with this cache, when you push an object or put an object of specific type which matches this condition, so it will follow these rules of mapping, of types mapping.
That's a property, an artifact of this particular thin client library.
It's a property. What I've just discussed, this type mapping, yes, because it's specific to language, and this specific to this library. However, the thin client protocol is based on the binary object format, so that's just the spec.
Last question. I'm very interested by the fact that you can refer to fields by name in the binary object.
Mm-hmm.
Are you compiling actual resolve references to that offset in the binary structure at that point in order to do that type of structured field acquisition by name on the server side?
So there is in this specific whatever I discussed today, there is no server-side work involved at all at this point. However, binary objects. So binary objects format is it's a standard Ignite API, and when you use binary objects, it's basically implemented. It's already implemented on the server side. So it's been.
Okay, so that example where you got by field name, that was also in a thin client that was examining.
Right. So this what I showed, except this part, is all thin clients. Is all thin client protocols. This one is REST. I'm sorry, I didn't fully get your first question. Can you repeat it? Because I think I.
That's okay. It was really the binary object protocol that was done a long time ago. It was called Corba.
Yeah, I think this is where the confusion comes from. It's binary object format. It's not the protocol. It's the format for object serialization, nothing more.
Well, that's pretty much what Corba was.
Okay.
So it's okay.
Yeah, thanks. Thanks for your questions. Yeah, thank you. Yeah, please go.
So it sounds like you have 4 different clients, right?
Yeah, so I have.
And the way you set it up is 3 clients feeding the data, and 1 client is receiving the data and presenting the message.
Right.
So in this case, you basically just use the Ignite as a cache server.
Yeah, exactly. It's a distributed cache for all the applications that consume this data, or yeah.
So to summarize, between thin client and thick client. So thin client is kind of like using the subset of Ignite, like cache, but you cannot send, for example, calculations, or cannot run like SQL commands.
So, no. So it actually, yeah. So first of all, it's not a part of the topology. It cannot. Yeah, it's not involved in caching. It cannot execute compute jobs. Thin clients can do SQL queries. Yeah, there is a. It's pretty much. Yeah, it's pretty sophisticated set of operations supported for. Let me just go to this slide. So you can inject data, you can query data, you can do binary type operations, and you can configure caches. So that's all you have. So it's a lightweight. So the main idea is that you don't bring up the nodes. You don't need this heavyweight Java environment. You can just write it like in a few minutes and actually start pushing data or reading data.
Any reason there is no like Java thin client?
There is a Java thin client. There is already, yeah.
I don't remember.
Is it thin or thick? Can it be considered to? Huh? Both. Yeah, there is, of course.
What about performance?
Yeah, that's a good question. So it actually, what do you mean by performance? Performance is a very wide concept. So if you're talking about runtime performance, it actually depends on the runtime execution environment. Even like even one language, just Java, may have multiple VMs running it. Python has multiple VMs. PHP. In general, we do comparison of clients to each other based on some most commonly used VMs and environments. And so thin clients, the idea is that it's really thin. All it does is probably some types mapping or some helper operations for applications. However, it's really thin, so there is almost nothing, no computations being done there. So it shouldn't be an issue at all. And it's also it's a good option for constrained devices, especially embedded devices, because it takes really just not that much space as, for example, and doesn't require that many resources as thick clients. Yeah, please go ahead.
Can it subscribe to an event, like you gave the examples with temperature and humidity? So the client has to keep on querying the server since it's not the part of the topology.
Mm-hmm.
So it cannot subscribe to an event like, so temperature changed after a day, but I have to keep querying like every minute. Like say I want an event more than 50 degrees centigrade, and it didn't change for 50 degrees centigrade for 1 day. So do I have to keep querying every minute, or like can I subscribe to the event?
Yeah, that's actually a very good question. There are no events that you can subscribe to, so you have to poll. It's like it's like a database a connection to the database. So you have a cache, you can query, you can do actually all sorts of operations, SQL queries, key value queries, or whatever. But yeah. There are no such things, because the main limitation here is the thin client protocol. If that would have this ability, and that's probably I would agree that's probably something that would be useful in some applications. Yeah, I think so. If it's supported on the thin client protocol, yes, it's then should be easy to implement here.
Like in your use case, like if a customer is using that, how many thin clients connect to your AWS? The grid cache.
Over here, it's 3 of them, and one is the HTTP, which uses it like HTTP API.
So in a production environment, is there a limit to number of clients, thin clients that can connect to your?
No, it's just a number of TCP sessions, I believe. Physical limit, I think, unless yeah. I would think so. Yeah, thank you. Thank you very much, everyone.